Hi and Assalamualaikum everyone. So today we are going to go into subtopic 2.2, which is quantum mechanics model. Okay, so this quantum mechanics model, the learning objectives will be to define the term orbital. Okay, explain the four quantum numbers of an electron in an orbital. Quantum numbers and LMS is what describes the address atau alamat, okay, of your electron in your atom. Okay, so which electron lives dekat alamat mana, and LMS dia akan berbeza. Okay, and then we will learn how to sketch the 3D shapes of S, P and D orbitals. So this is something new and it will be fun lah, I think. Okay, so quantum mechanical model is very important in understanding the nature of our electron, developing the idea of our electron in our atoms. Okay, if we recall what we learned last time, we learned of Bose. So according to Bose, electrons are restricted to certain energy levels. Okay, if you look here, we have n equals to 3, n equals to 2, n equals to 1. So Bose kata kalau electron tu is at energy level 1, dan dia punya energy adalah ini saja. Okay, tak boleh lebih, tak boleh kurang. If at energy level 2, it is this. Okay, so it is very restricted according to Bose. But if we recall Heisenberg's uncertainty principle and de Broglie's postulate, we find that our view towards electrons have changed, because they have said, we concluded that your electrons are wave-like and also particle-like. So that means that your electrons, dia tak semestinya akan duduk dekat satu tempat saja. Kita tak semestinya akan jumpa electron dekat energy level 2 saja atau energy level 1 saja. Okay, so unlike Bose model, okay, another person named Schrödinger has introduced quantum mechanical model. So this quantum mechanical model is widely used in chemistry now. Okay, so the quantum mechanical model, it does not attempt to describe the electron's path around the nucleus. Maksudnya not by E equals to 1 equals E equals to 2, E equals to 3, very restricted macam Bose cakap, but the region of space where the electrons may be. So region of space maksudnya satu ruang, okay, ruang where your electrons may be. So like here, okay, dia tak restrict to certain energy levels, tapi awak punya electron dia macam it is like a cloud. Okay, so dia berterabur, kita tak tahu dia kat mana. Dia ada region of space yang your electron live at. So the term that we will use in quantum mechanical model is orbital. So orbital is the home of your electrons, where your electrons live. Okay, so orbital is a three-dimensional region in space. Three-dimensional because kita define the space with the terms x, y and z axis. Okay, macam here, let's say this is your S orbital, we have x, y and z contohnya. Okay, so three-dimensional region in space around the nucleus. Okay, your nucleus is in the middle, where there is a high probability of finding an electron. So if you look back, okay, here yang paling gelap ni kat tengah ni ada nukleus, kat situ paling banyak elektron lah. Okay, tapi dekat luar pun, luar ni pun ada lagi elektron juga. Okay, so we have p orbitals and d orbitals as well. Okay, s, p and d orbitals. Okay, so your orbitals is basically the home of electrons. So how do we address, okay, apa alamat elektron kita tu? It is actually by using quantum numbers. Okay, so quantum numbers, there are 4. We have principal quantum number with the symbol n, angular momentum atau azimuthal quantum number with the symbol L, magnetic quantum number M, okay, ataupun sometimes some books will write ML, but let's stick to this. And then you have spin atau electron spin quantum number. Okay, awak punya electron pusing macam mana with the symbol S or MS. So I will basically use these two symbols lah instead of yang ni. Okay, so bila awak ada N, L, M, S, okay, macam ni. And then you have your numbers, okay, comma, okay. So this will basically be the address of one electron. Okay, so kita boleh tahulah elektron ni tinggal kat mana dalam awak punya atom. Alright, so NLMS is the address, okay, of where your electron live within your atom. Okay, which orbital, which shell. Okay, so let's look at the first quantum number, which is principal quantum number ataupun shell basically with the symbol N kecil. So principal quantum number will determine the energy level, okay, ataupun the electron shell and size of an orbital. Okay, so N will tell you the size of your orbital and the energy level. Okay, so you can have N starting with 1, bukan 0, okay, 1, 2, 3 and infinity. So as your N increases, the orbital becomes larger because N is basically the shell kan. So lebih banyak shell, then your orbital will become larger lah. Okay, and as N increases, the electron has higher energy. Okay, maksudnya electron dekat N equals to 1, the first shell will have this energy. Okay, as you go to the third shell, okay, this electron, contohnya this electron will have a much higher energy. It becomes further away from the nucleus, so it is more unstable lah. Okay, less stable. Okay, so the larger the orbital, the less stable the orbital, the less stable the electron actually. Okay, so let's say if you have the first shell, okay, the N equals to 1, this is the orbital size, okay, and then when you have N equals to 2, the orbital size will increase and so on. It will increase because awak tambah lebih banyak shell. Okay, pada masa yang sama, your energy will also increase. Okay, energy of your electron. Okay, next we have the second quantum number, which is angular momentum quantum number with the symbol L. Okay, so it has other names. Okay, it can be called subsidiary quantum number, azimuthal, or even orbital. Okay, so orbital maksudnya sebab you know that it will give the shape of your atomic orbital. Okay, kalau tadi energy atau shell, sekarang L will give the shape of your orbital. Okay, so the allowed values, okay, for L are 0, 1, 2, 3 and sampai N minus 1. So maksudnya you cannot have, bukannya infinity lah awak punya L ni, okay, bukan infinity. You will have certain allowed values depending on your principal quantum number. Okay, so the letters are assigned to different numerical value of L. So let's say if you have L equals to 0, the symbol will be S. S ni apa? S will be the orbital. Okay, your spherical shape orbital. So it is spherical, bulat macam ni. So if you have L equals to 1, okay, that means your symbol is P. This is the P orbital and the shape is dumbbell, like this. Okay, this is dumbbell shape. If your L is equals to 2, Okay, the symbol is D for d orbital. The shape will be clover leaf generally, but you also have other shapes for d orbital. Okay, so basically L will give you the shape of your orbital. Okay, shape of orbital, and it will depend on n, your principal quantum number. So a collection of orbitals with the same value of n is called a shell. So that means if you have 2s, 2p, 2s and 2p is within the same shell because you have the same value of n. Okay, one or more orbitals with the same n and l values are called subshell. So basically, let's say you have 3s. Okay, within 3s you will have 2 electrons. So this is called subshell or orbital. Okay, so your electron with the same n, 3 and l, let's say tadi 3s kan, so 0. Okay, kalau sama dia punya n dengan l, maksudnya dia adalah dalam subshell yang sama. Okay, atau orbital yang sama, which is 3s orbital. Okay, those 2 electrons. Okay, so let's say so your L value, it depends on the value of n. Okay, so let's say if you have n equals to 1, okay, your L will equal to 0 only. Why is that? Because we know that the possible values for L, okay, will be 0, 1, 2, 3 and until n minus 1. So kalau awak punya n is equals to 1, that means that the possible value for L is, okay, 1 minus 1 is just 0. Okay, so maksudnya you only have one shell. Okay, that means you only have one s orbital. Okay, so the shape of your orbital will be s orbital lah. Let's say if you have n equals to 2, maksudnya n equals to 2. Okay, so your L will be, boleh ada 0 and n minus 1, which is 2 minus 1, which is 1 only. Can you have L equals to 2? No, you cannot, because maximum awak punya L is n minus 1. So in this case, it is 2 minus 1, which is 1. Okay, so that means that in the second shell, okay, when n is equals to 2, in second shell, you can have 2s orbital, okay, which is spherical shape, and 2p orbital, which are dumbbell shapes. Okay, so maksudnya you have 2 subshells, s and p orbitals. Alright, so if you have n equals to 3, okay, maksudnya in the third shell, okay, n equals to 3, your possible values for L will be, okay, kita start daripada 0 boleh, 1 boleh, sampai 2 only. Kenapa? Because maximum is n minus 1. So in this case, it is 3 minus 1, which is 2. So maksudnya, we will have s orbital when L is equals to 0, p orbital when L is equals to 1, and d orbital when L is equals to 2. Okay, so maksudnya we can have these 3 shapes, okay, within your third shell. So you will have 3 subshells. You will have 3s, 3p, and 3d orbitals. Alright, within the third shell. Okay, Okay. Next quantum number is magnetic quantum number M. Okay. So magnetic quantum number describes the orientation of orbitals in space. Maksudnya tadi kita dah ada kita punya spherical shape as orbital. Okay. Spherical shape of as orbital X, Y, and Z. And then we also have our p orbital X, Y, and Z. Okay. So these orbitals dengan d orbital juga, they can have different orientations. Maksudnya kedudukan yang berbeza. That means dia boleh duduk dekat axis yang berlainan. Okay, axis yang berlainan between the axis. Okay, so that is what is meant by orientation of your orbitals in space. So tak semestinya semua awak punya p orbital duduk macam ni je dekat, let's say, x axis. Okay, contoh. Okay, your p orbital, it can also sit at the y axis. So bila awak lukis awak punya axis, okay, make sure dia consistent lah, jangan tukar-tukar kedudukan. So let's say awak punya p orbital boleh duduk dekat y axis juga. This is py orbital, this is px. So kalau pz pula dia akan duduk dekat z axis lah. Okay, so the possible values of your M, your magnetic spin quantum number, will depend on the value of L. So maksudnya dia akan depend on the shape of your orbital. So let's say we have M, generally the possible values for M is minus L, whatever in between, 0, whatever in between, and plus L, maximum dia. Okay, so let's say the allowed values for, ini salah ni, patutnya tak letak sini, ni cancel lah. Okay, so let's say if we have L equals to 0, okay, maksudnya awak ada S orbital which is spherical shape, you will only have one possible value for magnetic quantum number. So awak ada M equals to 0 saja. This means you only have one value of M, which means one orientation of your S orbital. Okay, so awak punya S orbital tu kenapa dia ada one orientation saja? Sebab when you draw X, Y, Z, okay, your S orbital is spherically symmetrical. So maksudnya dia bulat saja. So kalau awak tukar-tukar pun awak punya axis, let's say macam ni, saya tukar Z, Y, X, okay, awak pusingkan awak punya, awak letak the same thing, it is still the same. Okay, it is still the same. So awak punya S orbital tu, it only has one orientation. Okay, kedudukan dia in space. Okay, unlike when L is equals to 1, which is p orbital, we know that it is dumbbell shape macam ni. Okay, it can have minus L, what, 0, plus L. So in this case, you can have minus 1, 0, and plus 1 possible values for M. So that means you have 3 values for your magnetic quantum number. Okay, 3 values meaning 3 orientations of your p orbital. So this actually refers to px, py, and pz. So asal awak ada L equals to 1, your M will, you will have 3 possible values for M. You will have 3 values of M. So you will have 3 orientations of your p orbital, which is px, py, pz. So maksudnya macam saya tunjuk tadi lah, X, Y, Z. Okay, this is px in this orientation. Kedudukan ini awak punya orbital. Okay, kedudukan ini. So kalau X, Y, Z, okay, py, kedudukan dia macam ni. Different orientation, okay? Okay, so one more. X, Y, Z. Okay, now PZ. So awak punya dumbbell shape dia sitting on the Z axis. Okay, so this is the example for p orbitals. You will have three different orientations. Okay, so it doesn't actually matter -1 ni X ke Y ke Z ke. Okay, these are just values. So senanglah kalau letak ini X, PX, PY, PZ, just like, you know, to be uniform lah for your understanding. Okay. Okay. If you have L equals to 2, that means you have d orbitals, which are generally cloverleaf shaped. You will have 5 values of M. 5 values of M means that you will have 5 orientations of your d orbital. Okay, so when L equals to 2, 5 values meaning 5 orientations of your d orbital. Okay, so you have dxy, dxz, dyz, dx square minus y square and dz square. So these shapes I will show you later because they macam lain sikit. Okay, but it's not impossible to understand the shape. Okay, so that is M, magnetic quantum number, telling you the orientation of orbitals, kedudukan orbital in space. Dia duduk dekat axis mana, which axis. Alright, finally we have the last quantum number, which is the electron spin quantum number. So this is the final characteristic lah atau address for your electron. Okay, yang ni maksudnya macam contoh kalau alamat awak ini adalah let's say nombor rumah lah, nombor rumah. Okay, bukan nombor rumah, never mind. Okay, so electron spin quantum number represents the direction of an electron rotation on its own axis. So awak punya electron tu dia actually berpusing-pusing, terpusing-pusing. Okay, so each electron can only spin either clockwise or anti-clockwise. So you can only have 2 possible values for S quantum number, spin quantum number, just plus half or minus half. Okay, so let's say plus half ni adalah for clockwise lah, clockwise. Okay, bila punya electron, okay, let's say dia dalam S orbital, dia pusing clockwise. Okay, ini minus half is anti-clockwise. Okay, ni awak punya electron dalam S orbital, okay, tapi dia pusing anti-clockwise, ke arah yang opposite lah. So contohnya, if you have PX PX, okay, orbital. Okay, kalau dia plus half, contohnya kita cakap plus half tu clockwise kan. So awak punya electron kat sini, dia pusing ke arah clockwise. Clockwise. Okay, clockwise ke sana. Dia pusing macam tu. Okay, itu dia punya electron spin. Kalau minus half maksudnya dia pusing ke arah sana lah, anti-clockwise. Okay, so electron spin awak ada 2 je value, plus half dengan minus half. So